Hey everyone, welcome. Today, we're going to crack the code on one of the most feared topics in SPM chemistry, redox reactions. Yeah, that one. But don't worry, we're going to turn that confusion into confidence. Let's get into it.
But first, before we dive deep, just a quick reminder. The absolute best way to make this stuff stick is by actually doing it. So feel free to head over to wmcqpm.com or just scan this QR code, and you can practice tons of SPM questions. It's seriously the best way to get sharp.
All right, so you open your exam paper and you see this. What's the first feeling? If your brain kind of just freezes up or starts to scramble a little bit, yeah, that's pretty normal.
Trust me, you are not the only one who feels that way. It's a super common reaction. But I promise you, stick with me through this explainer, and by the end, you're going to look at this and know exactly what to do.
So, here's our game plan for today. We'll start with the basics. What even is redox? Then we'll build up your essential toolkit. After that, we'll learn how to spot the difference between reaction types, we'll solve a real SPM question together, and finally, we'll talk about how you can truly master this.
Okay, let's jump right into section 1. Let's get the big picture. What on earth is a redox reaction anyway?
So the textbook definition sounds kind of scary, right? A chemical reaction, change in oxidation state, transfer of electrons. Whoa. Okay, let's just push the jargon aside for a sec. All oxidation state really means is it's a number we use to keep track of an atom's electrons. It's like a score. But let's make this way simpler. At its heart, redox is just about trading. That's it. Think of it like this. One substance decides to give away its electrons, and another one comes along and takes them. It's a package deal. They always happen together. One gives, the other takes. That's the whole story. All right, section 2. To solve these problems, you need the right tools. So let's build your essential toolkit. We'll start with the two main processes, oxidation and reduction. Let's lay it out side by side. Oxidation means you're losing electrons. You can also think of it as gaining oxygen or losing hydrogen. Now, reduction is the complete opposite. It's gaining electrons, losing oxygen, or gaining hydrogen. See that? They're perfect mirror images of each other. Now, trying to remember that during a stressful exam? No way. So here's your secret weapon, oil rig. Just say it with me. Oxidation is loss, reduction is gain. And we're always talking about electrons here. Seriously, this little phrase is a lifesaver. Burn it into your memory. Oil rig. Okay, real talk. Let me tell you about the common traps I see students fall into all the time. First, they mix up oxidation and reduction. But you won't, right? Because you've got OLIRG. Second, they forget that these two are a team. You can't have one without the other. And the third, this is the big one. They make a tiny mistake assigning the oxidation numbers, which throws the whole question off. Okay, let's move on. It's time to learn how to apply this. How can you look at any random reaction and know instantly if it's redox or not? It all comes down to recognizing the patterns. Check out this comparison. On the left, we've got our redox reactions, like displacement or combustion. In these, electrons are definitely on the move. But look at the right side, the non-redox reactions, like precipitation or neutralization. For these, it's more like the atoms are just swapping partners at a dance. Nobody is actually giving or taking electrons, so their oxidation numbers, their score, stays exactly the same.
All right, this is the moment. You've got the theory, you've got your toolkit. It's time to go back to that intimidating question from the start and crack the code together. Here it is again. It might still look a little complex, but the difference is now we have a process. We have a plan. Okay, let's walk through it. Step 1, and this is the most important part. Assign the oxidation numbers. Any element that's all by itself, like the zinc on the left and the copper on the right, gets an oxidation number of 0. Easy. Now for the compounds. In copper nitrate, CuNO32, we know the nitrate ion has a charge of -1. Since there are 2 of them, that's -2 total. So for the whole thing to be neutral, the copper must be +2. We use the exact same logic for zinc nitrate on the other side, which means zinc is +2. Done. Now step 2, find the oxidation. We're looking for the number that went up. Well, look at zinc. It went from 0 to +2. It increased. An increase means it lost electrons. And OIL-RIG tells us oxidation is loss, so zinc was oxidized. Step 3, find the reduction. We're looking for the number that went down. Copper started at +2 and ended at 0. It went down. That means it gained electrons. Reduction is gain, so the copper ion was reduced. And there we have it. Since we found both oxidation and reduction, we know this is a redox reaction.
And hey, don't just take my word for it. This quote is pulled straight from a past paper explanation. It says, the zinc atom donates electrons. Donating, losing, it's the same thing. It's oxidation, just like we figured out.
See? We did it. We took a big, complex problem and we broke it down into simple, easy steps. So how do you get so good at this that it becomes second nature?
If you take only one thing away from this whole explainer, let it be this. To spot a redox reaction, you have to hunt for a change in the oxidation numbers. If any element's number changes from the reactant side to the product side, boom, you found one. That is your ultimate clue.
And now it's your turn. The only way to make this knowledge stick is to practice. So go on, scan the code, visit the website, and just work through as many questions as you can. That's how you turn this understanding into real confidence on exam day.
So I'll leave you with this final thought. Redox isn't just something in a textbook. It's happening all around you. A nail rusting, an apple turning brown, the battery that's powering the device you're watching this on, it's all redox. So now that you know what to look for, where else do you see it in your daily life? Think about it. Thanks for tuning in.